Okay, so this video is about writing the polar form of our complex numbers, and it's the same thing we did before when we were converting rectangular to polar. We're just going to put a new form of our complex number, but with polar coordinates. So we already know that a plus bi, and what this is that exact same form. So if you think about it, a is r cosine theta from over here, and b is r sine theta, just like before. Remember, this is our x and our y. So r cosine theta plugged in and r sine theta plugged in would just give us this. And so the short form of that is r cis theta. So how we start this is to convert our rectangular 1 comma 1 here, because this is 1 plus 1i. Our a is equal to 1 and our b is equal to 1. And we're going to convert it to our radius and theta just like we did before. So r is equal to the square root, and then remember we square each one. So that means r is the square root of 2. And again, it could be plus or minus depending on our theta. So tangent theta then is again 1 over 1. So all we're going to be doing is theta equals inverse tangent of b over a. And so in this case, it's 45 degrees. And you want to always verify it. So 1, 1 would be like right there. That would be 1 plus I. I know it's at 4, but you get the idea. And so what angle does that make? That's 45 degrees. So that checks perfectly. And square root of 2 is our radius. And so what we're getting here is that answer. And so how you write it is square root of 2 and then cis 45 degrees. And you can do lowercase if you want or capital. But what this stands for is cosine I sine. And so if we change this is square root of 2 cosine of 45 degrees plus square root of 2 sine of 45 degrees, and that's your I. So instead of putting the I at the end, we just put it here. So if you read it, it's square root of 2 cosine I sine. If we plug this in our calculator, if you remember cosine of 45 degrees, right, is square root of 2 over 2. So multiplying that would give us 1. And square root of 2 times square root of 2 over 2 would also be 1. So plugging this in our calculator like this gives us 1. So all we're doing is taking that number and converting it back to the radius and the angle that with a cosine and a sine would give us the a and the b that we need. So square root of 2 cosine of 45 is 1. Square root of 2 sine 45 is 1. So these represent the same thing. So this would be 1 plus I, just like we started. So this is our polar form of our complex number. So you can see here that an angle of 45 degrees with a radius of square root of 2 here gives us our location of 1 plus 1i. And so even if we had made that a negative 1, now our angle would be 135 with the same radius. But the 135 is what we need to get it over here at the negative. And if our b was negative, same thing, the radius would be square root of 2, but we'd need 225, so our theta would change. You guys good? So there you go. There would be the negative 1i. So 1 plus negative I, 315 degrees. So we're just finding the angle and the radius that would give us the same location. So if I do square root of 2 sine of 315, it would give me my y, and square root of 2 cosine of 315 would give me my x, my a, and my b. So let's try another one. So again, all you're doing is pulling out your a and your b in point form. So negative 1 comma rad 3. So our r is the square root, negative 1 squared plus rad 3 squared. So that's square root of 4, and that's 2. So now we know our radius. So location-wise, we're over here in quadrant 2. So we're going to need that angle to get us here and a radius to get us there. So let's move on to the next part. So theta will be the inverse tangent of b over a. So what is the inverse tangent of the square root of 3 over negative 1? So it's negative 60. So this is negative 60. So we need to take our radius of 2 here and our negative 60. So what angle would we actually be using? So if you think about it, this right here is negative 60 degrees. So to get it to go all the way back here, all we're going to do is add 180 degrees. Put that nicer. Plus 180 degrees. So if we add 180 degrees to this, we get 120. So now we know it's 2 cis 120 degrees. And how do you make sure that that's correct? We just plug it in our calculator. So we're going to go 2 cosine 120 and 2 sine 120. So you can see 2 cosine of 120 gives us our A. And then this is, remember, it's 2 cosine I sine. So this is the I, the imaginary. So 2 sine of 120 is this, and I just verified it with rad 3. So there you go. 2 cosine 120 gives us negative 1, and 2 sine 120 gives us radical 3. So it'd be negative 1 plus radical 3i, which is what we wanted. Negative 1 plus radical 3i. You can also use my Desmos calculator to verify it. So I put in negative 1 for my A part, my real part, and radical 3 for my imaginary part. And you can see it gives me an angle of 120 and a radius of square root of 4, which is 2. But there it is. It has to be the same location. That's the key. All right, so the last one is one that we're just going to use for thinking. I don't want to see any work on this one. So 0, 4i would be right here. Right here. That's 0 plus 4i. So you should be using your number one tool here, your brain. What angle is that? That gives us that location. And you should be saying 90 degrees. And then what radius will also give you that? So if you know you're going from here to here, and that's our 4i, then the angle from here to here is 90 degrees, and your radius is just 4, because you're at 4i. So you would just write 4 cis 90 degrees. No work needed, and there you go. And if you plug it in, if you do cosine of 90, you would see that that would be 0. And then sine of 90 would give you 1, so it would be 4i. See? So for cosine of 90 degrees, this is 0. And then for sine of 90 degrees, this is 1. And so there it is, because it's cosine I sine. So this would be 0 and 1i. And there you have it. So every single one, same thing. Now let's try it in reverse. And it really is a lot quicker here. So all you're going to be doing is writing 4 cosine of 150 plus 5 sine of 150 and then putting the I. So it's 5 cosine I sine. And we plug this in our calculator. So 5 cosine of 150, that's our real part. So we get this. And just to verify it, you already knew it was rad 3 over 2 for 150. So negative 5 rad 3 over 2 is this. And then 5 sine of 150 is 2.5 because we knew that was a half. So half of 5 is 2.5. So we're going to be writing this for our real part and not 2.5 but 5 halves for our imaginary part. So this is 5 rad 3 over 2 plus I 5 and then 1 half, which gives us our nice 5 rad 3 over 2 for the real part plus 5 halves I for the imaginary part. And there's your complex. So that's it. All you have to do is plug that in. Should you still verify it? Yes. So 150 would be here, right? And this is why you verify it, because we make little simple errors all the time. Our radius is 5, so we should be in quadrant 2. Does our point give us quadrant 2? So I'm going to give you a hint on why. It's our calc output. This is negative, so our real part was supposed to be negative. So this is really negative. Remember, cosine is in quadrant 2 here, which makes it negative. So now it matches. We should have a negative real part and a positive imaginary part. And so we can see now our angle of 150 with a radius of 5 gives us this location. And there is our negative 5 rad 3 over 2 and our 5 halves. So it's quadrant 2. Just always verify. With the second part of converting, if you already know your polar, plugging in the calculator will give you the correct location, but it's good to check. Okay, so just to do one more, that's supposed to be I there. This would then just become 3 cosine of 150 degrees plus 3 with an I sine of 150 degrees. And so this would just become negative 3 rad 3 over 2 plus 3 halves I. And again, 150 puts us in quadrant 2, which would be a negative imaginary, a negative real, and a positive imaginary. So you can see here, if I just change that to 3 and that to 3, it gives us the same thing. There's our radius of 3. So it's the 150 is giving us the rad 3 over 2 negative. And so the radius is just getting placed in there, and it's giving us that total distance. So if I were to change that to a 4, it would just give us a radius of 4. So again, it's just the angle and the radius multiplied together with the cosine and sine to give us our complex number. And so just a quick review, you're using the complex to give you the rectangular coordinates and then converting them just like you did before, and then giving it as a radius and an angle, the rad 2 cosine I sine, cis, cosine I sine. And then if you're working in reverse, you just literally plug it in the calculator and it's giving you the answer or the unit circle. Thank you.